And yeah, let's just get into them so you can understand more what they are. So the first few questions, we're talking about exponents. So based on previous experience with numbers, find the value of x in each equation below. So just like common sense, just thinking about it. If I have 2 to the x, what number does x have to be for it to equal 16? So you have to have 2 to the 4th, right? 2 to the 4th is 16. And if you needed to test it out, you could go 2 to the 1 is 2, 2 to the 2 is 4. You can just keep trying. 2 to the 3 is 8 until you get to 16. So you can just keep testing it out. So that means x would have to be 4. Okay? So we've done a little bit with exponents. So I just want you to think about the next 3 and see if you can figure it out. See if you can just think about what value would x be to make this equation true. So you can pause the video and you can work on that, and then we'll go over it. Okay, so coming back to it, with this, again, you could test it out if you want. Just see what 3 to the 1 is, 3 to the 2, 3 to the 3, 3 to the 4. Just start with those. See if you can get there. So 9, 27, 81. Oh, hey, that works. So that means x is 81. So if you needed to test them out, you can. Otherwise, you can also just think about it. The next one, for us to get 1, what does the exponent have to be? Well, x has to be 0, right? Anything raised to the 0 power is 1. Okay. Last one, see if you remember. What raised to the exponent gets us to 1/3? Well, let's see if you remember how to get a fraction. So 3 to the -1 gets that, because what happens when we have a negative exponent? If you remember from your exponent properties, a negative drops, makes the exponent go to the bottom of the fraction. So to get rid of the negative, we bring it down to the bottom. And now the exponent is positive. Okay, so that's how we work with negative exponents. Okay, so when you have a fraction, it means you have a negative exponent. So now, we're gonna look at the next ones. So the next ones don't work out perfectly like the ones above. So there's no whole number that you could plug into that to get 50. It's gonna be a decimal. So I want you to provide an estimate. So what 2 numbers would x have to be in between? So you can think about it this way. 5 squared equals 25. And then what's 5 to the 3? Well, that's 125. Does 50 fall in between 25 and 125? Yeah, it does. So that means x has to be in between 2 and 3, right? Because we're looking at the exponents. Okay, so you're going to give an estimate because it's going to be a decimal. It's going to be 2 point something to get us to 50. So I want you to try that with the next ones to see if you can find an estimate of where it would fall. So you can pause it right now. Okay, coming back. So going to the next one. You can just try 2 to the 2 is 4, okay? 2 to the 3 is 8. 2 to the 4 is 16. Well, we're not quite up to 20 yet. But then 2 to the 5 equals 32. Okay, well 20 falls in between 16 and 32, so that means x has to be greater than 4, but less than 5. Okay, it's going to be in between those. We don't know exactly what it is. It's a decimal. It's 4 point something. So let's go to this next one. Okay, trying to get -16. Well, negative values. Well, let's see. We got 4 to the 1 is 4, so that's too high, so we need to go down. 4 to the 0 equals 1, so we got to go further. 4 to the negative 1, we'll do negative numbers. Well, again, do we remember what negative numbers do? They make a fraction, right? We bring that 4 to the bottom of the fraction. That's what negative numbers do, negative exponents. Well, 1/4, that's not negative. 1/4 is still positive, and we need a negative. So there's actually no values for x that will work. There's no exponent that will give us a negative value. Okay, so we can't have negative answers. And the last one, if actually we'll skip this last one. It's kind of hard. We won't go over it, but if you got it, x has to be greater than -3 and less than -2. But we won't go over that one. You don't really need to know that much. Okay, so now with these exponents, with 5, 6, and 7, we couldn't find a specific x value because x was a decimal. So we need something to help us figure out what these missing x values are when they're exponents. And that's going to be a logarithm. Logarithms and exponential functions are inverses. This means that we can switch x and y, right? So you remember from the last 2 classes, we just continued to switch our x and y values when they're inverses. And we can switch our x and y values on a graph or in a table, and the graph will reflect over that line of reflection. So remember, the line of reflection was that diagonal line that went through the center. Okay, so logarithms and exponentials are inverses. So we can use logarithms to help us solve exponents. Okay, so this is the form we write a logarithm in. How we read that is log base b. So this b is a base. So log base b of y equals x. That's how we read it. And we can switch back and forth between a logarithm and an exponent. So you can see the b, the base of the logarithm, is the base of the exponent. The answer of the logarithm is the exponent. And what we're taking the log of is what we're trying to, or the solution for the exponent. Okay, so you need to know how to go back and forth. So where the base is, which values are the exponents, and which ones are the solutions. Okay, so if you remember going back here with this exponent, there are certain x values we couldn't use. And so that comes down here. If we can use logarithms if and only if y and b are positive numbers, okay? So this y and b in here, they have to be positive. You can't have negative numbers. And b also just can't be 1. So our base can't be 1. So we say, so again, it's log base b of y. So we're going to practice rewriting our logarithms as exponents and our exponents as logarithms. So here we have a logarithm. So you can look up top here if you need help remembering. So what's the base of our exponent? Well, the base is the base of the logarithm, so base 2. And which one's going to be our exponent? Well, remember what the logarithm equals is the exponent. Okay, and what we're taking the log of is what the exponent equals. Okay, so let's do the next one too. Question 10. So now question 10, we're going to take the exponent and rewrite it as a log. So again, the base of the exponent is the base of my log. What the exponent is what it's going to equal. And what my exponential equation equals is what I'm taking the log of. Okay? So I want you to practice for question 11, 12, 13, and 14, switching back and forth. And again, just look up top here to help you switch back and forth between the two forms. So you can pause it and work on that. Okay, coming back here. So the base of the logarithm is the base of our exponent. What the log equals is our exponent, and what we're taking the log of is what it equals. So 3 squared does equal 9. The equations should make sense. Okay, let's go down here. So log base 3, right? The base of the exponent is the base of our log. What it equals is what we're taking the log of, and the exponent is what we're trying to find. Okay, so again, log base 10 of 1,000 equals 3. And the last one, 3 to the negative 2 equals 1/9, because negative exponents make a fraction. Okay, so going to the next one. Now we're going to practice solving logarithms. So we don't quite know how to solve logarithms yet. We're going to teach you a bunch of different skills to solve logarithms in the next lessons. So right now, we're going to use exponents, and we know exponents, okay? So we have to use our number sense. And so to help us solve this logarithm, we're going to change it to an exponent. So what's the base of the exponent on 15? Well, the base of the exponent is 3. So my exponent is x, and it equals 1. So using this exponent, what does x got to equal? Well, x needs to equal 0. Okay. So again, with 16, we take the base of the logarithm, raise it to x, and it equals 1. So again, for us to get 1, what does x need to be? X needs to be 0. So we're using this to help us solve the logarithms. So this last logarithm, log base 9 of 1 equals x. Let's solve for x. So the base of my logarithm is 9 to the x equals 1. And again, what does x equal? X equals 0. So with question 15, 16, and 17, do you notice a pattern that when we take the logarithm of 1, what happens? What does x equal when we take the logarithm of 1? Well, it always equals 0. So looking right here, log base b, so regardless of the value of b, so regardless of the base, whenever we take the logarithm of 1, it's always going to equal 0. So that's just a quick little hint for us, that whenever we take the logarithm of 1, it's always going to be 0. Okay, so I want you to try 18, 19, and 20 and see if you notice a pattern. So you can pause it here and see if you notice what the solutions are going to be. Okay, so let's go with 18, 19, and 20. So again, let's change this to an exponent to help us. So the base is 9, our exponent is x because that's what we're trying to find, and it equals 9. Well, for us to have the same thing, x has to equal 1. Okay, let's go to the next one. Base is 7, it equals 7, so again, x must equal 1. And here, the base is 13, it equals 13, so x must equal 1. So here, when the base of the logarithm matches what you're taking the log of, so 9 and 9, here it was 7 and 7, they match, here 13 and 13. So when they match, no matter what the number is, it's always going to equal 1. Okay, so these are some special logs that now when we see that, whenever we see that we're taking the logarithm of 1, it's going to equal 0. So these are just shortcuts to help us with solving. Now the last thing is there's some special types of logarithms. So Leonard Euler, so it's pronounced Euler, was an accomplished Swiss mathematician. His career spanned almost all areas of math and provided the groundwork for many important equations used in the world today. One of the most important numbers is named after him. So the number is E. So E represents a number, just like how pi represents 3.14, and some of you might know more of them, but it continues on. That's the same thing with E. It's 2.71 and then a bunch of numbers that continue on for forever. So that's why we give it a letter, just like how we gave pi a symbol. E is just a symbol to represent that number, okay? And so we have a special logarithm that uses E. So the two main logarithms we have is base E and base 10, because 10 is just a nice number to use. So these are our two special logarithms. So the first one is a natural log. So natural logs are the ones that use base E. So you see we have a logarithm here, and the base is E. So it's actually represented, though, how we write it is ln. That's just Latin for log natural, or however the Latin is. That's why it's ln. And that's how we write this special natural log. So whenever you see ln, what is the base? It's base E, okay? So even though we don't write the base, we don't write the E down there, we know the base is E, okay? So let's see if you can solve these special logs. Yeah, down here. So this is natural log of 1. So again, do we remember what happens when we take the logarithm of 1? What does it equal? And if you need to remember, you can go up here. When we take the log of 1, no matter what the base is, we get 0. And here, the natural log of E. So remember again, what's the base on the natural log? Well, the base is E. So if the base matches what we're taking the log of, what does that equal? It equals 1. Okay, so those are natural logs. Those are special logs. And the reason they're special and I want you to know about them is because it's one of the only logarithms you can type into your calculator. So if you have a calculator on you, you can look and you can see that there's a number or a button that says ln, and that's the natural log. So this is why this is special, because it's on the calculator. That's why you need to know about it. The other type of logarithm is called a common log. And that's the one with our base 10. So common log is base 10, and because it's so common, we just write it without the base. So whenever you see a logarithm without a base, you know it's base 10, okay? We just kind of don't worry about the 10. Just like with a square root. You know a square root, technically the little number there is a 2, but we just don't write it. Same thing with the logarithm. The base is 10, we just don't write it. And again, the special thing about common logs is it's in your calculator. So you see that log button on your calculator? That's a base 10 logarithm. So again, base 10s are nice because you can use your calculator. So here, when you take the logarithm of 1, you always get 0. And here, with this logarithm, even though we can't see the base, we know it's base 10, and since these match, the answer is 1. Okay, so today's not too hard, just introducing you to logs and some special types of logs. So now you can just work on the homework.